BATE Tutorial 4 of Basic Computer Science.
Question 1. Convert the decimal number into binary representation. 1a 46. Therefore, the solution to convert all the decimal to binary, we use a repeated division by 2 method and remainder read from bottom to top. Give us the binary value. Therefore, 46 divided by 2 get 23, which lead to 0. 23 divided by 2 you get 11.5. Therefore, you must write 11 and the remainder remain 1. Therefore, 11 divided by 2 you get 5.5. Therefore, you must write 5, the remainder 1. Therefore, 5 divided by 2 you get 2.5. Therefore, the remainder remain 1. Therefore, you put 2. 2 divided by 2 you get 1, no reminders. Therefore, you put 0. Therefore, 1 divided by 2 you get 0. The remainder will be 1, because 1 divided by 2 you get 0.5. Therefore, the remainder will be 1. Therefore, 46 decimal number into binary will be this. This is the answer. Question 1, part B. Solution: convert decimal to binary. Therefore, 93 divided by 2 we get 46.5. Therefore, remainder will be 1. Therefore, 46 divided by 2 we get 23. Remainder will be 0. 23 divided by 2 we get 11.5. Remainder will be 1. 11 divided by 2 we get 5.5. Remainder will be 1. Therefore, 5 divided by 2 we get 2.5. Remainder is 1. 2 divided by 2 we get 1. Remainder is 0. 1 divided by 2 we get 0.5. Remainder will be 1. Decimal number of 93, the answer will be this one: 1 0 1 1 1 0 1, binary number. Question 1c, 167. Solution: 167 divided by 2 you get 83.5. Remainder is 1. 83 divided by 2 you get 41.5. Remainder is 1. 41 divided by 2 you get 20.5. Remainder is 1. Therefore, 20 divided by 2 you get 10. Remainder is 0. 10 divided by 2 you get 5. Remainder is 0. 5 divided by 2 you get 2.5. Remainder is 1. 2 divided by 2 you get 1. Remainder is 0. 1 divided by 2 you get 0.5. Remainder is 1. Therefore, the answer of 167 decimal number into binary will be 101001111 as a binary number. This is the answer. Question 1D, 72.5 decimal number converted into binary. Solution: first integer of 72 we must convert it first into the binary number. Therefore, 72 divided by 2 we get 36. Remainder is 0. 36 divided by 2 we get 18. Remainder is 0. 18 divided by 2 we get 9. Remainder is 0. 9 divided by 2 we get 4.5. Remainder is 1. 4 divided by 2 we get 2. Remainder is 0. 2 divided by 2 we get 1. Remainder is 0. 1 divided by 2 we get 0.5. Remainder is 1. Therefore, the answer of 72, this is the answer: 1001000. Second, we convert the fraction which is 0.5, where the conversion of 0.5 division lead to multiplication. 0.5 times 2 is equal to 1.0. Therefore, 1 divided by 2 is equal to 0.5, which remainder is 1. Therefore, this one remainder we add it to the integer of 72, which is the result answer will be this one: 1001000.1. This is binary number of 72.5. Question 2, convert the binary into decimal number. Question 2a, binary number 11000001. Here we apply this formula, 2 bracket 2 power n bracket, and add sum of them. Therefore solution of this binary number, therefore we count them. 1 times 2 raised to 5 bracket plus 1 times 2 power 4 bracket plus 0 times 2 power 3 bracket plus 0 times 2 power 2 bracket plus bracket 0 times 2 power 1 bracket plus bracket 1 times 2 power 0 bracket. So those power, this one will lead to 32, this one will lead to 16, this one will lead to 0, this one will lead to 0, this one will lead to 0, and this one will lead to 1. Those one will lead to 0 because 0 times certain number is 0. Therefore adding 32 plus 16 plus 1 will lead to 49. Therefore 49 is a decimal number for this binary number being shown here. Question 2b, this binary number 2 decimal. Therefore 1 times 2 raised to 6 plus 0 times 2 power 5 plus 0 times 2 power 4 plus 0 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0 on brackets. 1 times 2 power 6 is that to 64. This one is that to 0, this is that to 0, this is that to 0, this is that to 4, this is that to 2, this is that to 1. Adding them is that to 71. The full binary number of this into decimal place or decimal number is 71. Question 2c, convert this into binary solution. As we start, we set it with the binaries which don't have the decimal point, so it will become this one. Therefore 1 times 2 power 5 blanket plus 1 times 2 1 times 2 power 4 blanket plus 0 times 2 power 3 blanket plus 0 times 2 power 2 blanket plus 0 times 2 power 1 blanket plus 1 times 2 power 0 blanket. Therefore 2 power 5 will become 32, this will become 16 plus 16 plus 0 plus 0 plus 0 plus 0, and this last one will become 1, therefore leading to 49. Therefore fraction party 0.01 will become, therefore we take 0 times 2 power negative 1 blanket plus 1 times 2 power negative 2 blanket. Therefore this will become to 0, this will become to 0.25, which is equal to when adding 0.25. Therefore when converting this, when taking 0.25 adding 49 with that to 49.25, this means this binary number is decimal place is this one, decimal number. Question 3, convert hexadecimal number to binary number. A3a, A5 solution. This means that A5 represents, A represents 10 and 5 we don't know what it represents. We must find out. Therefore we must convert hexadecimal number to decimal number first, and then to convert them to binary. Therefore because it started the hexadecimal started A5, 10 times 16 power 1 blanket plus 5 times 16 raised to power 0. Therefore this will be 160 plus 5 is equal to 165. 165, this is a decimal number. Therefore we must convert it to binary number. When converting to binary number as shown in above is simple. We divide by 2. When it's finished without no remainder, it puts 0, but when it finish, it doesn't it remains remainder, we put 1. That's this answer. 3b, question 3b, FA9. Solution. Simple. We know that the hexabinary decimal table, it is simplified and it is easy one to use. This is the hexabinary table. Hexabinary table, which convert hexabinary table into binary. As you can see, F represents 15, where in hexabinary decimal table 15 represent F, which F in binary is 1111. Okay, A represent 10, but in hexabinary decimal table 10 represent A, which is 1010. In hexabinary decimal table represent this one. Even when you convert it, you will get this one direct. When converting this hexadecimal number into binary number, we combine all of them and result into this. This will be the answer of the binary number of that hexadecimal. FA9. Question 3CB. Solution. C represents this in hexadecimal binary number table. C represents 12, as we can see. C represents 12, which is 1100. B represents 11, which in hexadecimal binary table 11 represents 1011. Therefore, when we combine them, we get to the answer. We start with 3 coming to 12 coming to 11, which is the answer will be this binary number, which represents hexadecimal of 3CB. Convert the hexa into decimal number. Hexa A5 into decimal number. Solution. We go direct. 8 represent 10. Therefore, 10 times 16 raised to 4 power 1 plus 5 represent 5 times 16 power 0. Therefore, this will be 160. This will be 5. Adding will be 165. As from the previous question, you can see. Therefore, result of A5 hexadecimal into decimal number will be 165. Question 4b. Hexadecimal FA9. Solution. F represent 15, will be 15 times 16 power 2 plus, this is power 2 because this is power 0, this is power 1, this is power 2. Therefore 15 times 16 power 2 blanket plus 10. A represents 10 times 16 power 1 blanket plus 9. 9 is equal to 9. 9 times 16 power 0. Because this will become 3840 plus 160 plus 9. When adding, result total became 4009. As we finish with 4C, represent question is 3C. Therefore, this C represent 12, C represent 3. Therefore, 3 times 16 power 1 blanket plus 12 times C represent 12. 12 times 16 power 0. Therefore, this result to 48. This plus this result to 12. Adding them result to 60. Therefore, hexadecimal 3C representing decimal number of 60. Question 5A, 5B, 5C as follows. Those are the answer. Let's start with question 5A, then 5B, then 5C. 5A, explain how image files are represented in computer. Image file involves a grid of tiny dots called pixels. Each pixel is assigned in a binary value that represents its color. For black and white images, a 0 might represent a white image and 1 represent a black image. Question 5B, effects of color depth and resolution. The higher resolution means more pixel per inch. More pixel require more bytes to store, increase the file size. But the color depth, this is the number of bytes used to present the color of the single pixel. Increasing color depth allow more color, but significantly increase the file size. Question 5C, this involves hexadecimal RGB color. Each hexadecimal RGB color has its own codes, and each code represents its own color. As you can see, this code FFA500 represents orange, and as the 4 code you can see FD00DD, this represents magenta.
For more and last question, solving more, subscribe, please. Benefit is coming, subscribe and share.